Hi, this is Anvesh. Now I'm going to explain the ICP1 for the cybersecurity. So in this ICP1, I need to run the four notebooks, tensors in PyTorch and neural networks with PyTorch and training neural networks and fashion MNIST classifying. So let me start with the first one, tensors in PyTorch. So this is an introduction for the deep learning with the PyTorch. First of all, here we can you can see the how we can use the tensors using the PyTorch. First of all, I'm importing the torch package, and then I'm adding one activation function. So there are different activation functions, but I'm using some torch activation functions. From this activation function, after that, I'm generating some data. Then the features of the five random normal variables. So from that, I'm going to print weights dot shape and the features dot shape. So you can see here weight dot shape is 1 and the features dot shape is 5. Then in this part 1, our exercises, I need to calculate the output of the network with the input, features, weights, and bias. So I'm given weights t is equal to weights dot view of I comma 1. I'm using a torch dot sum to calculate the weights of to calculate the sum of weights and bias by using the torch dot sum, and I'm printing the output activation. So you can see these are my output activation function. And next, comes to the next one. I need to calculate the output of the little network using matrix multiplication. So here we can see the same thing. Weights dot view is equal to 5 comma 1. I'm using here 5 comma 1, and here, and the same thing, I'm torch dot sum. I'm multiplying the futures with weights, and plus I'm putting the torch dot sum of bias. And finally, I'm using the activation function to put this output. At last, I will get the output activation as 0.1065. So like this, I need to calculate the multi-layer output for the multi-layer network using the weights W1 and W2 and the bias B1 and the B2. So for this, I'm using toss.mm. Just I'm taking the futures comma weight as a bias, as a parameters, plus I'm adding that one to the bias, and I'm passing that one to the activation function. This is the one output I got, and in output 2, I am passing this activation function comma weight 2 plus bias, and in that time we will get some output. That output I am passing to the activation function, and I'm printing that activation function. So you can see I'm getting the value as 0.3171. So this is the part 1. Next, when it comes to the part 2, we're doing the neural networks with the PyTorch. First of all, we need to import the necessary packages what we need for this PyTorch. These are numpy package and torch, and this matplotlib package is used to plot the graphs, like some bar graphs and line graphs, something like that. You use this package. So first of all, I'm extracting the data, MNIST data for here. Next, and you see here, iterating the train. For each image and label. So as I said, I download the data set of MNIST. Um, from that, I'm iterating for each image and the label present in the train loader, and I'm iterating that one, and I'm getting the image comma labels, and I'm printing the image comma labels and labels dot shape. You can see here this output, and I'm using that plot package. I'm using plot.imshow image first image dot numpy dot squeeze. So this is the image I'm getting here. So in this my exercise, I need to flatten the patch of images and then build a multi-layer network with 784 input units and 256 hidden units and 10 output units using random tensors for weights and bias. So here, first of all, I'm creating an activation function. Input is equal to images dot view. Torch dot random is equal to, as a given 784 input and 256 hidden in units. And here for the weight 2, I'm giving the 10 output units. So I'm passing this to as an activation function, and I'm printing the neuron dot shape. So you're getting torch dot size of 64 comma 10. So like this access. I need to build a networks with a PyTorch. In this exercise, we'll do the neural networks with PyTorch. Then when it comes to the third one, we need to train that neural networks what you have been done in the part two. So in this, I'm just importing the necessary packages what we need and define a transform to normalize the data, and we need to download the training data. Uh, So in this exercise, I need to build a model that returns a softmax as an output and calculate the loss using negative log with likelihood loss. So here you can see I'm building a model with the necessary functions, ReLU activation function, linear, and log softmax. So I am defining the loss using nn dot nn loss, and from this already we download the data and put in the train loader. So I'm iterating the train loader and I'm getting the images comma labels, and I'm trying to view the images comma labels. Loss is equal to criterion of logs. I'm calculating the loss using the logits and the labels. And what is the loss I'm calculating? I'm just printing that loss. So you can see the loss I'm getting is 2.3219. And next so these print, I need to initial the weights. What is this? Like I'm going to train the network here. Train for the real. So here our exercise and this, I need to implement the training pass over network. If you implement it greatly, you will see the training class drop with each epoch. So here's my solution. I'm giving the necessary values like in an activation function, something like that. I'm calculating the loss, and here I'm using SGD optimizer, and I'm giving 5 number of epochs for this. So for each epoch, for each images in the train load, I'm iterating it. I'm going to calculate the loss for that. So as you said, for each epoch, you can observe that the training loss has been gradually decreasing here. So this is part 3 notebook, and when it comes to the part 4 notebook classifying fashion MNST, first of all we need to do import necessary packages what we need, and we need to download the data and put the data into some training data and the tested data, and so you can see here we are creating a definition called IM and show, and I'm creating this some I'm trying to put some images from the data what have been downloaded. So I got this image. I'm building the network using this model is equal to nn dot sequential of, and some activation functions what we need. I'm passing after building the network. I'm train the network by define the criterion and the optimizer what we're going in training the network. I'm using the number of epochs. So number of epochs for I'm iterating for a number of I'm iterating 5 number of times. Suppose if I give the 10 epochs, I need to iterate for the 10 number of times, and I need to calculate the loss. So for each epoch the loss will be gradually decreasing. So here I'm putting all the features like what is present in the data. Fashion actually I download fashion data so that I am putting t-shirt, trouser, pullover, dress, coat, sandal, something like that. And here you can see I'm using the view classify method to see the image what you are getting, and what is the probability is the image, and the probability what you are getting is matching. We are just checking here. So you can see here the boot, and you can see the probability here is matching. So both the probability is matching. So you can say that we are on the right way, getting the right result. So this is ICP1 for this is the task what we need to do for the ICP. Thank you.